my lecture today, I would like to discuss with you our most recent concept when it comes to the understanding of skin aging phenotypes. And this concept is closely related to the skin aging exposome. Just as a reminder, we perceive the development of skin aging phenotypes, in particular of extrinsic skin aging phenotypes, to be the result of genomic factors, but most importantly also of non-genomic factors or non-genetic factors, for which we use the term exposome. So, the exposome. What is the exposome? This term was coined by Dr. Christopher Wilde in 2005, and it refers to the totality of all exposures an individual is subjected to from conception to death. Or in other words, it is the lifelong exposure to non-genetic factors. Some years ago, we asked what is known about the skin aging exposome, and we had to realize that in fact it is poorly defined. And this surprised us because the skin is a barrier organ, and because of this, there's no doubt that skin aging is, of course, also due to many non-genetic factors. And in 2017, we have published this review paper in the Journal of Dermatological Science, in which we provide the first definition of the skin aging exposome, which reads as follows. The skin aging exposome consists of external and internal factors and their interactions affecting a human individual from conception to death, as well as the response of the human body to these factors that lead to biological and clinical signs of skin aging. We also conducted a systematic literature review, and based on this we proposed that environmental factors which are part of the skin aging exposome fall into the following major categories. First of all, of course, exposure to solar radiation, to sun radiation, then exposure to tobacco smoke, to temperature. Nutritional factors are very important, stress factors are important, lack of sleep, and also exposure to pollution. I will now focus on some of these in some more detail, and I would like to start with the most important one, which is clearly solar radiation. And the first point I would like to make is that it is not only the UVB part of the solar spectrum, but also UVA, visible light, and shortwave infrared radiation or IRA radiation, which significantly contribute to the development of skin aging phenotypes. And there is also evidence that this is not only specific for rodents, but this is also relevant for human skin, and that this is of relevance for photoprotection if one wants to protect human skin against photoaging, as we point out in this position statement that was published last year in the Journal of the European Academy of Dermatology and Venerology. And there are indeed ways how this can be done, and currently the most effective one is to use topically applied antioxidants, and this is just one example. These are results from a vehicle-controlled double-blind randomized study in a total of 30 human volunteers. We have exposed their skin to IRA radiation and then taken biopsies to look at the transcriptional expression of the MMP1 gene as a molecular surrogate for wrinkle formation. And as expected, there is a significant increase, and this can be almost completely inhibited if we pre-treat the skin with a sunscreen, which does not only have an SPF 30, but also contains an antioxidant mixture, and you can see that this provides significant protection in contrast to the SPF 30 sunscreen without antioxidants. Another point is that it has become more and more clear that long wave UVA, in particular UVA1, but also the blue light part of visible light are important when it comes to uneven skin pigmentation, to the formation of melasma, post-inflammatory hyperpigmentation. You can see that just by using pure visible light, it is impossible to induce pigmentation in human skin, and this can be further enhanced if one combines it with UVA1 irradiation. And in this manuscript, they carefully measure the degree of pigmentation and can then show that this effect is actually synergistic in nature. So if you want to protect human skin against solar radiation-induced skin aging, then protection should include protection against UVB, against UVA2, but also against UVA1, against visible light, and IRA. The other exposomal factor I would like to focus on in more detail is pollution. Just to remind you, pollution comes in different categories, and in the context of this presentation, I will mainly talk about particulate matter, which is synonymous for diesel exhaust particles, for industry exhaust, or for soot. It is present all over the world wherever we have large urban agglomerations, and we and others have shown that this is very important for skin aging and pigmentation. But for the sake of completeness, I would also like to stress the fact that it has been linked to the pathogenesis of several skin diseases, in particular eczema and skin cancer, and there's circumstantial evidence at least that it might be important for urticaria and possibly also for acne vulgaris. These are the human skin equivalent models, and you see that already after 2 exposures to diesel exhaust particles, they start to darken, and this is even more the case after 3 exposures. And of course this can be quantified by chromametry. So these are delta eta values. The smaller the get, the darker is the skin, and you can see that there are already significant effects after 2 and even more so after 3 applications of diesel exhaust particles. So is this really melanin? And the question is yes, this is an experiment in which we quantified the total melanin content, and you can see that in comparison to untreated ex vivo skin models, in the treated ones there is a significant increase in the total melanin content. Thus far we have been talking about isolated exposomal factors, but a very important part of the definition that we have provided is that the skin aging exposomes does not only consist of external and internal factors, but also of their interaction, and that this is also very important for the development of phenotypes. And more recently we started to look at this, and one interaction that we were particularly interested in is of course the interaction between air pollution and solar radiation, because when we are walking outside we are usually exposed to both exposomal factors simultaneously. And the results have been published in the Journal of Investigative Dermatology 2 years ago. We believe that this interaction might take place at the level of the skin, so that photo-aged skin might show a susceptibility towards PM, which is different from the one of sun-protected skin. But this interaction might also occur at the level of the troposphere, and there is evidence in the literature that ultraviolet radiation can photochemically alter particulate matter, and this might have consequences also for the bioreactivity of PM that is then hitting human skin. So now we have mainly talked about the exposome and about the different exposomal factors and their interaction, for example, the interaction between solar radiation and air pollution. But there is, of course, also an interplay between all these exposomal factors and the genome, because at the end of the day, the genome defines the genetic susceptibility towards all these different exposomal factors. What is the relative importance of different exposomal factors? And we are able to establish hierarchies. So, for example, we can clearly show that by far the most important exposomal factor assessed for the formation of coarse wrinkles is exposure to ultraviolet radiation. The second most important one is exposure to tobacco smoke. Then on third position we have air pollution, and on fourth position we have nutrition. But this is very different, for example, for facial antigenes, for age spots. Here nutrition is very important. On the second position, we have air pollution, which is at least as important as exposure to ultraviolet radiation, and the least important is tobacco smoke. If you have further questions, if you're interested in the details, I would like to refer you to a review paper that I published again this autumn in the Journal of Investigative Dermatology, and I would like to thank you for your kind attention.